Hi, everyone. Welcome to the Software Craftsmanship Software Craftspeople community. The Software Craftspeople community is a non-profit organization that connects people with software craftspeople mindset. We organize expert talks, roundtable discussions, and workshops to enhance the community's skill and knowledge in software development. Our community is founded by Incubyte. Incubyte is an organization dedicated to crafting well-engineered and high-quality software solutions with a focus on helping customers in their modernization journey. Today we have Adam Tornhill. I'm quite a fan on a personal level. Hi, Adam. Adam Tornhill is the founder and CTO of CodeScene, where he designs software engineering intelligence tool to help companies succeed with software development. He's also author of multiple technical books, including the best-selling Your Code as a Crime Scene and Software Design X-Rays, which is one of my favorite books, as well as an international keynote speaker and software researcher. Thanks a lot for joining us today, Adam. Everyone on the call, please feel free to find Adam on Twitter and LinkedIn and follow him. That being said, let's get started, Adam. Do you want to? I think we can get started with one of the papers that I had read recently from you that actually talked about technical debt. And of course, for the audience who doesn't know a lot about software design X-rays or Your Code as a Crime Scene, Adam has done a lot of research on technical debt. And I think one of the things that anybody has a lot of it's an uphill battle, right? To convince your managers or their managers how technical debt impacts the business. A lot of time developers cannot articulate it, and all they can say is something like the code doesn't look good or it's not right? But what the managers or their managers want to hear is what is the business impact of technical debt. And Adam had just a few months or maybe a year back had written a paper on business impact of technical debt on business, right? So Adam, why don't you tell us a little bit about how does technical debt impact a typical business and maybe revenue as well? Does it have any impact on a company's revenue or expenses?
Sure, I'd be happy to do that. And hello, everyone. Really good to be here. I'm very much looking forward to talking with you. So is software important to a business? Is code quality important to a business? Yes, it's a massive competitive advantage. The problem is that we have never really been able to prove that. And with prove that, I mean by having numbers. And consequently, I think that we as engineers, we have been like on the losing side of most arguments, right, about larger improvements. And the reason for this is because the software lacks visibility, right? I mean, I've been writing code for 30 years, and I find it hard to reason about software. And now, can we expect someone that doesn't have any prior technical background to jump in and understand a million lines of code? It's simply impossible. So I also think it's part of our responsibility as software engineers to, be able to let our non-technical stakeholders peek into our otherwise inaccessible world of code. And this is pretty much what I've been working on for the past 10 years. Now, what did we do? Well, me and my research colleague, Dr. Marcus Borg, we teamed up and we collected data from lots of organizations. We wanted to focus on proprietary software because otherwise you have that argument that, yeah, maybe open source is different, right? And besides, we wanted to prove that it actually has a business impact. We needed companies that have a business model and depend on software. And what we did was that we collected data from lots of different companies. And we used a metric called code health. So code health is something we use as a proxy for code quality. I can go into the code health metric in more detail later, but it's basically it's a collection of metrics that we weight together. So we look for various complexity patterns. We look for various design qualities like high cohesion, loose coupling, that kind of stuff. Then we weight all of that together and we come up with a code health classification where we can say that a piece of code is either healthy or it's unhealthy. If it's unhealthy, it means you have technical debt, you have design issues that make that code really, really hard to evolve. Now, what we also did was that we collected data by connecting to their project management tools. So Jira, Azure DevOps, Trello, those kind of tools. And by doing so, we could collect data on how long does it take you to implement a new feature or fix a bug, depending on if your code is healthy or unhealthy. And what we found was pretty interesting. What we found was that on average, if you have healthy code, you can move more than twice as quick as someone that has red code. And what I like to think is that this is pretty relevant to a business, because now we can go to our manager and say, you know, if you let us improve or refactor this unhealthy piece of code, we're going to be able to move twice as quick with all these 5 things you have on the product roadmap touching that area, right? So now we can suddenly have a business conversation around it where we can weight refactoring and improving the design versus new features, right? What we also shown, which is I think even more impactful, is that we have shown that if you have unhealthy code, it can actually take you an order of magnitude longer, 10 times longer to implement a new feature, because red code, or as I call unhealthy code, has a lot of uncertainty, right? There are so many surprises hidden in that code. And uncertainty is something that no stakeholder likes, right? So your manager might very well have promised a customer that, hey, we're going to ship this feature in a month. If you have unhealthy code, they can make no such promise. It could equally well take 10 months, right? And this is something they are not comfortable with. And if in that situation, everyone has already seen that happen, right? You have missed deadlines, you have shipped something that disappoints your customers. And now you can actually show data on why that's the case. So that also means that refactorings can come with a business expectation. You can say that not only are we going to be twice as quick if we improve this, we're also going to reduce the uncertainty with an order of magnitude. And that's a big, big win. So that was a pretty lengthy initial response, but I hope I managed to clarify a little bit of it.
You did, Adam. So I think what you're saying is that one of the value proposition of not having technical debt is the speed that you can work with, which means that you could actually go much faster, and also the predictability that you could actually predict when you will be done with something, right? But there's something I have realized, Adam, and I don't know what's your thought on it. Technical debt doesn't necessarily happen in companies where the engineering culture is great, right? It actually is also behavioral issue, how people work. Um, and in those places, sometimes the delays are not happening because how fast you can write code, but delays are happening because, let's say, your PRs are waiting for a long time, or people are taking code. So you're just in a queue call ready for QA, a queue call ready for release, a queue call product analyst review pending, something like that. And the delays are also happening. So do you think there's a correlation between how your code looks and how is your company culture?
Yeah, that's a super interesting topic. Yeah.
Okay. Do you have any thoughts? And this is suddenly I know I am sort of throwing this question out there, but this is an interesting thing because you talked about delays, and the delays, it made me think that, hey, delays actually happen a lot of time, not because of coding speed, but just things being stuck somewhere.
Yeah, so I do think that it's all connected. And I'll also like to point out that technical debt as such is not necessarily a bad thing. There might be situations where taking on technical debt is exactly the right thing to do. However, these situations are not as common as we like to think in the software industry, right? But the thing is that if you have really, really great situation awareness of your code base and you know exactly where the strong and the weak parts are, then you can use technical debt as a lever, right? You can say that, okay, we have this thing, it's so important that we get it out tomorrow, right? That we can cut some corners because we know what the implications are of doing that, and we have visibility into what happens when we do that, right? So you can use it as an advantage in certain situations, but it requires a great engineering maturity. Otherwise, things go wrong. And as you point out, I think that if you work in a company that has a lot of technical debt, you're also likely to see, problems in other parts of the software delivery pipeline too, right? So one thing you mentioned is, of course, reviews being a bottleneck. This is not that surprising because reviewing unhealthy code is a very expensive thing to do. It's really, really hard, right? And what I also tend to see, if you have a lot of technical debt, then changes are, they're almost never local, right? They're always large sweeping changes in highly complex code, right? So the PRs are really big, which is another barrier to reviewing them. And I also think that quite often the problems start earlier. Maybe they start when we take our understanding of customer needs, break it down into stories or requirements or whatever we call it, right? And I think already there, we might not, in many cases, we're not as clear as we should be. We're not as scoped as we should be. And we take on way too large chunks of work all the time, which is another thing that drives uncertainty. So yes, I think it's all connected.
Okay. Actually, now that you talk about it, it makes all sense, Adam. We've been working lately a lot on direct, and there's like a direct correlation between how much it takes, like a lead time to production, and how happy developers are. So if developers are just waiting for something to be approved, they are actually not, neither are they productive nor they are happy. And if build times are taking a lot of time, again, their experience is not the greatest. If release time is taking a lot of time, if test is taking up, so of course, they are correlated. And this is all different kinds of technical debts, right? So if you worked on, let's say, automated testing or even documentation or build speed, test speed, I think you're right. The developer experience gets better, and so does the culture. I believe you're right. You're right. But you also mentioned something interesting, right? Adam, you said that sometimes going ahead, like choosing the path of technical debt, maybe just the right thing. Then how do you weigh the short-term benefits, of cutting corners as opposed to the long-term cost, right? So when do you think it's just the right thing to do, thinking short-term as opposed to long-term?
So what I do is that I use two different perspectives, so two different measurements to help me make that decision. The first is, of course, the code health metric. So I need to know, is the code good or bad, right? That's one of my decision inputs. The other one I need is the relevance of that piece of code. And in that case, I use a technique I call hotspots that I write about a lot in my books. So hotspots is something that you cannot see in the code. Hotspots is something you calculate from looking at the behavior of the developers. So what we basically do is we look at the commit frequency of every single piece of code. How often do we modify a piece of code? And when you look at that, what you quickly see is that most of your development activity is in a very, very small part of the code base. So these are the hotspots, the development hotspots. And taking on technical debt in a hotspot is extremely expensive. It's something I never do, and I never recommend anyone to do it, right? A hotspot always needs to be healthy. However, what you see with hotspots is that they always form a power law shape, right? So you have a very, very long tail in your code base. And taking on technical debt in the long tail could be a viable option, right? Because that code has so low interest. But you need to have that situation awareness. You need to understand that this is a non-hotspot, right? And it's acceptable to do this. Otherwise, you're just guessing, and that's really dangerous.
Makes sense. Makes sense. And I think most of us over here are developers today on the call. And if they had to communicate as a developer the impact of technical debt to their product and business managers who are non-technical, what would be the right way? How would they do something like that?
So what I do, and this is one of the main reasons that I founded CodeScene, is that I wanted, I basically envisioned CodeScene as being a communication tool between engineering and the business. So what I've been doing over the past years is that when I talk to non-technical stakeholders, I'm very, very heavy on visualizations. And my experience is that once you visualize software, once you visualize its code health, its technical depth, that tends to be something that resonates a lot with business people. You obviously need to explain to them what the visualization does and how it looks. But once they get it, they tend to appreciate it because they are also not comfortable not knowing at all what happens in that black box we call IT, right? So that's the first thing I do is I visualize it, and I could, maybe I can grab the screen for 10 seconds and just show you what it looks like. So we all, because I think it's hard to explain in just words. So let me do a very quick example. Should be able to see my screen now. So this is what I mean. This is how I visualize a code base. And basically what you see here is a structure that follows the structure of the code. So we have different subsystems and modules, storage, pipeline, REPL, and so on. And once we go to lowest level of detail, we see each file with source code visualized as a circle here, right? And now the color obviously reflects how healthy that code is. So we have everything that's green, that's healthy code. Everything that's red, that's unhealthy. We have lots of technical debt. And yellow means that the code is problematic. So you have tech debt, but it's not as severe as the unhealthy code. So this is what I use a lot to show them where is your technical debt. What I do next is that I go and pick up that white paper me and Marcus Board wrote last year and show them that, okay, this is the business impact of having red code. And once we have that shared understanding, then we can start to have these really meaningful conversations. We can decide, do we go ahead with a particular feature or capability? Even if we know that the code is unhealthy, we can do that, but then we need to plan and be comfortable with taking on that massive delivery risk. Or we use this data to go back to the drawing board and say, okay, maybe we should use this as a driver to finally improve the design of that piece of code and pay down the tech debt. So that's what I do. Does that make sense?
It does. Though while you were explaining it to me, I think one of the things that occurred to me is, do you even need to discuss technical debt with your managers? I think that's another question that I would have. And this is based on, I recently was reading this book called Tidy First. I'm not too sure if it's a recent book by Kent Beck. And as I was reading it, it said how you should always couple structural changes with behavioral changes. So you are doing, whenever you're making a change to a behavior, you first extract a function, make it smaller, do some structural changes that makes the change easy first. You do a PR, fix the PR, and then you do the behavior change. So what you're actually doing is you're not even talking about technical debt. You're working on technical debt, but you're not telling that, hey, let's, like, in that case, do you think if that could be another strategy, which is, hey, technical debt is just coding in itself, doesn't need to have its own name. Whenever you're adding behavior change, you just figure out how to, and just make it our responsibility. Nobody else has to know.
I think it's I think it depends. So when it comes to smaller things, I think you should never ever have to ask for permission to refactor or something crazy like that, right? You really just do it, right? It's part of the job. If you have a feature to implement, the code is messy, you clean it up and you make the change. I think that's a no-brainer, right? That any sane manager will understand. But what I'm talking about is more these code bases, and I think we've all seen them where you have tons and tons of problems, and you cannot solve that by simple refactorings, right? It's not a PR, it's work that might take you weeks, sometimes even months. And as such, it's work that's going to be a trade-off, right? You can either improve this code or you can implement or try to implement this next big feature. And I think it's super important to have these conversations in the open, to be very transparent about that yeah, this is the problem we have created it ourselves. You want me to do these features, we cannot do them safely because the code is in such a bad shape. So now we need to pay down that tech debt, right? And we can do that driven by data. We can see the return on investment for the business as we do that. And I think that's very important to draw that distinction between these two different types or degrees of maintenance issues.
I understand what you're saying. And I think, yes, I went off track over here. If we are looking at modernization, software modernization, then what you're saying makes total sense, right? Where it's a huge project. But then I have a different question for you, and this is something that I had asked you earlier as well, Adam, which is, what do you see is the success rate of a typical modernization project? And I have a math sort of, right? If you look at a company that's been in the market for 10, 15, 20 years, let's say 20 years, and 20 developers has worked on it, let's say on an average every year 20. So you're looking at 400 years worth of engineering work that's gone into that product. So when I put it on as math, does it ever happen that you could have a task force of, let's say, 5 people, 10 people who could actually drive results that makes a difference?
Yeah, it's interesting with the success rate of modernization projects. I was trying to look up those numbers because I recently wrote about them. I did a second edition of Your Code is Crime Scene, and I remember that I looked up the latest research. But from the top of my head, I think that we have a pretty poor track record of modernization projects. They seem to be really, really hard to do. So it's clearly an expert area. And I think the failure rate is as high as 75% or something like that. That doesn't mean that people don't manage to, modernize, but perhaps they end up in situations where they still rely on the legacy system to some extent. So it seems to be a really, really hard thing to do. Does that match your experience too?
Yes, yes, it does. And it almost feels like it's a race that you cannot win, because there's this old app as well where the work is continuously going in. Uh, and you're trying to modernize in a very small sort of a silo team. So and then there are dependencies, there are multiple apps, and I think that becomes one of the reasons why the legacy system still ends up being there, because there are other software that still depend on the legacy system, right? So um, yes, and this math always throws me off a little bit, that hey, a typical software has been in the market. If it needs modernization, you're talking of upwards of 15 years. And if something lives upwards of 15 years, means it has had a good development team, right? So hundreds of years of years worth of work has gone in that software. How do you modernize that, and or how do you rewrite it, which is even tougher. So yeah, that question always keeps throwing me off, and that to not get to that situation, you have to like tidy first or continually do small refactoring, or say, but that's a harder problem to sell, because how do you tell someone to take your vitamins daily, right, or go to gym daily? Because this is, now you're talking about health, and it's rather easier to take a painkiller when there's a real pain, as opposed to like staying healthy the entire life, right? So have you seen that this good behavior is like harder to tell, preach, or sell to people?
Yeah, it's definitely harder, and that's pretty much what I'm trying to work on to, increase the awareness. And I think at the end of the day, it's a very, very human thing. So in my parallel psychology path, I learned about this decision-making bias called hyperbolic discounting. It's basically when we humans, we make choices today that our future selves are going to regret, right? It's a very, very typical thing. It happens all the time. But I think it's so pronounced in software, right? Because, the moment we have a new feature, we put it into production, right? We get some reward, right? We can finally close a sales deal, or we get a happy customer, or, whatever, right? So the feedback loop from putting a new feature into production is very quick. It's immediate. However, the feedback we get from technical debt or poorly written code is slow, right? It might be something where we see the consequences weeks, months, sometimes even years from now, right? Maybe the next time we want to expand on that feature, we find that it's so messy that we cannot make sense of it. And I think this difference in feedback timing explains a lot of what happens. So it's exactly the same thing with, when I go to a gym or I eat healthy, right? The benefits from that are long term. Whereas when I sit down in front of Netflix and eat chips, right? It's an immediate reward. So we have this hyperbolic discounting thinking all the time. And the way you counter it is that you start to prime decision makers, and decision makers can be yourself, or it can be a business manager. We start to prime us about the future risks. If you continue down this path, this is what's going to happen. Maybe you can see, personally, you go to a doctor and you see your blood sugar trends over time or something like that, right? For software, it's very much about visualizing the code health trends. Because if you see something that's is called code health and it goes downhill like this, then it's very clear to everyone that this is something that's happening here that's not necessarily a good thing. And if you want to communicate that to a business, then you also need something more business oriented. So maybe you look at things like, okay, what's our average lead time for shipping features, right? Is it increasing or is it shrinking, right? That tells you a lot about where you're heading. So I always recommend to focus a lot on trends, to counter these biases and make everyone aware of the trade-offs we're doing, rather than just looking at the snapshot right now. Because if we do that, then the short-term gains for new features are always going to win out.
Actually, that makes me think. I see also a chat message from Narendra that says someone has to be responsible to making sure the technical debt doesn't accumulate. But that makes me think someone has to be responsible because it takes a certain level of maturity to know what builds technical debt. But when people come from their colleges, when they're not so experienced, they just don't know about this concept of technical debt. So they're, they're accumulating it fast enough. And there's, of course, in this industry, we don't have many senior people, maybe less than half, right? So by the time someone understands that, hey, there's technical debt and we shouldn't increase it, there's already so much of it out there, right? And that makes me think, have you, I don't know, I haven't been associated with a lot of educational institutes or universities. Have you been? And I wonder if now this has become like a first class subject in colleges and schools where, hey, it's not what you write and it's not the syntax, but it's how you write your code is also important.
Yeah. So I've actually seen educators that do a really, really good job. I don't think it's mainstream yet, but I know to just call out some people I know. So I know Aslam Khan, who runs, who's involved with We Think Code in South Africa. They do an absolutely wonderful job on that, right? So they do a lot of brownfield work, right? So they pick up like large, dirty, messy code bases, right? And have students work on them. And I think that's absolutely brilliant because that's where you kind of experience the difference of proper design makes, right? In the traditional student assignment, I mean, it doesn't matter how you solve that code because it's a one-off thing, right? You're never going to maintain it. I also know that my colleague, Dr. Marcus Borg, he still teaches at the University of Lund. And one thing he does, for example, is that he uses CodeHealth as part of his education. He uses CodeScene to kind of, bring awareness to the consequences of poorly written code. So there are people that are, embracing this thinking and teaching students a very valuable skill, which I'm very happy to see, of course.
Exactly. And I think kudos to Aslam and Dr. Marcus for teaching it in the schools. But yeah, I think it should become, I know in many colleges, I think JUnit or some sort of a test framework is not even like discussed at all, right? So awesome if and better if it became mainstream over time. Anyways, we did talk about tidy first and refactoring. Do you think there's a rhythm of refactoring and reducing technical debt versus when you add more? Let's say if you want to keep, so there's this typical graph, right, that says that if you just kept working faster, then you'd go like fast in the beginning, but then it keeps going slower. So your productivity keeps dropping if there's a lot of technical debt. But let's say if you wanted to keep going, sort of keep increasing the speed and not let it decrease, then is there like a balancing act that you could do between refactoring and adding a new behavior? Like, is there a right amount of ratio or practice that you would propose to developers?
I think it's hard because I think over time, most software organizations will be slower. And I think that's simply because the more features you accumulate, the more domain knowledge you need and the harder it is, right? So there are ways around them, right? Where you can take, instead of having this large product you work on, you break it down into smaller products, right? And have teams super dedicated to one specific area. But then again, what happens is that then you have coordination between different parts. It's very, very hard to pull that off at scale. So I think some slowdown is almost inevitable, but I think the key is that slowdown should come from an increase in the complexity of the problem domain, not the solution domain, because then we are doing something wrong. And what I mean by that is that, yes, I think that when we implement new code or when we make changes to existing code, we have to pay very, very close attention and we have to do the necessary refactoring. I think one problem in our industry is that we have so much subjective rules, so many subjective IDs, right? And one person's golden refactoring can be technical debt for another, right? It's really, really way too subjective. So I think we need to, drive our behavior a bit more based on actual research, because there's actually a lot of stuff that we know in the research community that it works. And I think key is to have people simply take stuff from the research community and try to translate it into advice for the practicing programmer. So that's, I'm not sure if it helps, but I don't think it's a super simple answer.
No, you are right. And I know exactly what you're saying, because sometimes like you see these posts on LinkedIn and Twitter that just says, "Hey, you don't need testing." Like, just say something that's so opposed to like mainstream or even a little bit idealistic thinking, and they just don't do TDD, or you don't need testing. Testing that is, for a small product is not required, or something, and that's totally subjective take of someone, which I don't think so necessarily works in an enterprise or a bigger application, and then a lot of people would just repost them, or the recent. I don't know if you read the recent McKinsey report about developer productivity, which made a lot of rounds, and I'm not sure. Are you aware of the recent McKinsey report which talk about DevX and developer productivity?
I'm aware of it. I deliberately skipped reading it. I read
Yeah.
Daniel North's response to it.
Yeah, yeah. So yeah, you're right, but I think someone can say something, and I'm sure a lot of, and to be frank, that report didn't have a. I mean, it was not entirely wrong as well. It had issues, but I think not everyone can read between the lines, and not everyone can. So it becomes subjective issues. Who reads what, and people end up reading just what they like, right? So there could be like 10 lines that says, be very careful about how you write code. And then there's one line that says, it's okay if you didn't write test case in that one case. But people would just read that one line, and then never write test cases, or like, figure out a way, hey, to justify their own behavior.
And I think what a lot of those opinions lack is context as well, right? So there's a big difference. I mean, if you work on a business application and you mess up, you might create a problem, right? But if you work on something, let's say safety critical software, right, for the railway industry, right? If you work on something like that, then I'm pretty sure that all of us would like that software to be well tested before we step on a train, right?
Right.
The cost is so much higher. It's actually human lives on stake, right? And it's completely irresponsible to claim that no, we don't have to test software in general, right? It's simply not true. It depends a lot on your domain, the context.
Right. Agreed. I love the fact about what you said about subjectivity, and I wonder. The only book that I have read is Making Software, which has a lot of numbers, which tries to bring objectivity to the entire field. I wonder if there are, Adam, do you have any recommendations for the viewers over here for books that is about bringing objectivity to the field?
So unfortunately, I don't think there are so many books that do that in software. So Making Software is absolutely great. I like that one because it's academic a little bit, right? But it's still accessible, and there are unfortunately not many books of that quality. So I think the work that the Dora team did with Accelerate, that's another pretty good example, right? Where it's actually based on research, which is one of the reasons why I love that book. Now it's already 5 years old, and I think people are starting to misuse the Dora metrics, but it's very well intended and very solid work that they have done. I try to do the same. So with my books, I always include references to actual research to support the things, because I think that when you write a book or you give a talk or you give advice to people in the industry, I think it's our responsibility to do the best we can to make sure that what we recommend actually works.
Actually, you're right, Adam, and that's one of the things that I took away from software design X-rays. A lot of references to the actual studies and papers, and when I would read that, hey, code size or lines of code is a good proxy, let's say, for code complexity, with a research paper that kind of proves that it's more agreeable, so to speak, right? So, and lots of such research and references, it really helps. And once again, I think I would just recommend everyone on the call to have a look at software design X-rays and read it. But that being said, Adam, do you have any like best practices that you would suggest for organizations who want to introduce culture of continuous improvement, right? Otherwise, you kind of get stuck in an era where when you started and just stay there. How do you keep improving?
Yeah. Sure, I do. I've been working a lot with that, and there are some things that I think work really, really well. But what I think is important is that, of course, tooling, measurements, all that kind of stuff, it's really important. It's fundamental, but on its own, it's not enough. Someone has to care about what's being measured as well, which means you have to be prepared to change your processes and ways of working, right? These things have to be integrated together. So what I found when it comes to technical debt, the first thing I recommend is that wherever you are right now, put the quality bar on what you already have. I think that's step number 1 or 0, right? It's super important. So before we even start to talk about paying down technical debt, refactoring things, we should make sure that the code doesn't get worse. And the reason I say that is because if you manage to do that, you're already performing better than 80% in the industry. It's super important. How do you do that in practice? Well, you could use a tool like CodeScene to serve as a soft quality gate, right? So you get immediate feedback the moment you're declining the code health, you figure out that, okay, I did something that maybe I shouldn't have done, right? And you can act on it early. And I think the earlier you discover that, the better. So this is something that I think all developers should use as part of our development environment. But then I also think it's about having continuous conversations around this data together with our product people and our managers, right? So I always recommend people to use stuff like the visualizations I showed you earlier, right? Use that as part of your recurring ceremonies and activities, right? So if you have like a weekly planning meeting, make sure that you always start with the visualization like that, so that you know that, okay, these are the problematic parts, right? If we have any feature we're going to discuss that touches that part, we know that there might be dragons, right? So we have to be extra careful, and we can now start to discuss that based on data. And then also think that as a manager, you have a responsibility to stay on top of this stuff, and you have to show the team that you value this, that you value healthy code, because you know, your behavior is going to influence how your staff behaves. So if you push them too hard on the deadlines without also valuing that the code remains healthy, right? It's a no-win game, and there's no way we as engineers can create some kind of magic, right? It all goes together.
Actually, you're so right, Adam. And two things that your explanation makes me think about. First is asking right questions. And this actually happens, right? If people kept asking on different calls, will it be done on time? Will it be done on time? So if managers kept asking, will it meet the deadline? Then what will happen is only it will meet the deadline without any quality or any other thing. So based on what managers are asking, that's the result which will be achieved. So if the managers never talked about quality, asked about quality, very high possibility that it always takes the back seat just to get the results any which way in the given timeline. So, and it's not just about quality or timeline. I think it's about everything that you care about. If you care about something, you have to keep the conversation going and keep asking the right questions in your weekly, monthly, quarterly meetings. Even if it means, I think the highest level would be like, is the customer happy? And if you keep asking that question as well, I think a lot of things may keep falling in place. But then the second thing that you also said was, care about what's being measured and be able to change your behavior based on how your measures are. So this is kind of a good story. Some of the people over here may know it. We were measuring DevX experience so developers experience for our team. There are one or two places, one or two teams, we kind of realized that, hey, at one team, they're always creating a huge backlog in the beginning. And we're talking about like 300, 400, 500 stories, and then only kind of prioritize 15 or 30 every month, right? This huge upfront analysis of things. And then you're doing like little by little the work. There was, so your lead time to delivery actually reduces heavily. On the other side, there was one other team where we were measuring DevX DevX, and we found that, hey, there's so many tickets that will stay in ready for release state. So while everyone's focusing on how fast you could write code, your delivery was not going fast. And that's when we could make a structural change in the teams. None of this was actually code issues. These were behavior issues. So we started thinking about, hey, let's not do a lot of upfront analysis, or hey, let's not be anyone stuck in ready for release or ready for code review pipeline. But it almost feels like that the rest of the world loves any framework so much. So it's like, hey, Scrum, it has to be 15 days. Hey, it has to have every day, and it has to have a backlog. They are good frameworks, but I think that's what they are, right? They're frameworks for you to get you started easily. And once you've gotten started, I think you have to sort of customize it to your own way of working, to bring your own optimizations, to get better at how you work and your team works. So I think uh, you're so right. And I think the fact that you could only do all of these things if you're measuring how you are working, which I think not a lot of companies do. And of course, based on how many companies we have worked with, is this a common thing that you see across all the companies where they're actually measuring how their engineering teams are working, or any measures around those which can improve the engineering culture?
It's definitely a trend I see emerging. I think it's relatively common, and it starts to become more and more common. That doesn't mean that companies are necessarily always measuring the right thing. And this is what to give you an example. I like that story that you just shared, because I think it's super important to understand where the bottleneck is, right? Is it in us writing code that takes time, or is it that we're actually doing a good job there, but we might lack something in our delivery practices, right? So we have invested into some feature, it's ready, but our customers aren't benefiting from it because it's hanging around and waiting for an end of sprint review or whatever, right? That's waste. So what I've seen is that a lot of companies seems to pick up on the DORA metrics and use them as some kind of evaluation. I don't think that, I think there are two challenges with that. As I said, I like DORA, but I think that DORA really just focuses on, these are delivery metrics. You need something for the development side as well, right? Because if you lack in your development practices or quality, you're going to suffer in the delivery too. And second, I think that the DORA metrics, they're so easy to misuse. So I've seen companies that measure things like, okay, lead time for delivery, that's the time from opening a PR until we close that PR. That doesn't mean that the code is delivered. It just means that it's on your main branch, and if it lays around there for 2 weeks, you're going to fool yourself if you think that your lead time is like 1 day or 5 hours or whatever. So I think we also need to have a better understanding of how do we actually measure this? What is delivery for us, right? We have to be very open with these definitions and measure the right thing. Otherwise, we might do more harm than good. So it goes both ways.
Agreed, Adam. And I think that's why author of Accelerate, Nicole Forsgren, right? She wrote 2 papers on DevX as well, where she talks about exactly the same thing, that apart from your delivery metrics, you may want to measure these other things as well. Awesome. Um, have you, in your own experience, Adam, felt that, hey, because the code quality changed, it got better, the team's social behavior also got better? Like, and I think I'm repeating my question. We talked about it earlier as well, but based on your experience, have you seen a journey? Or actually, Adam, there was one of the stories that I had heard from you, is how modernizing. You had worked on a project where you started with a modernization project, and there was a huge team, and one of the reason it it wasn't succeeding was because there was a huge team, and it's actually when they became smaller, they had way better results. I'm kind of forgetting the whole story, but I'd love to hear that.
Oh yeah, I usually tell. I have a couple of stories like that I tell that I lived through, and so I'm not sure which one that was. One that I remember very well is that was back in the days as a consultant. So I joined a company. They had 5 in-house developers, so very small team. Was doing a small code base, right? And what they want to do, they wanted to modernize that code base because it was 10 years old. The code was written using a case tool that was no longer really supported, right? So it wasn't really maintainable. And they had some pretty solid data based on the historical development that this will take us 1 year to do. Now, what they decided to do was that 1 year to them wasn't good enough because there was a new marketing department. They wanted to have it out in 3 months because then they could hit some trade show in Germany that was important to them. So how do you do? How do you take a project that you know will take 1 year and you do it in just 3 months? Super easy, right? 4 times as many people. So they hired like 20 consultants and threw them in with the rest of the team. Initial architecture already set. And as you can imagine, they didn't ship in 3 months. In fact, they didn't ship in 1 year either. It took them 2 years to ship. And the only reason we managed to hit that 2-year deadline was because, first of all, we had to cut the scope. We had to ship with a number of known defects. But we also have to significantly scale down the team. We have to go from 25 people to just 10 people, just in order to be able to make any progress at all. And this is super counterintuitive. When you tell this to a business manager that don't know software, it's super counterintuitive that, we don't need more people, we need less. And the reason for this is because tasks on software are never perfectly parallelizable, right? So we always have dependencies between them. And the more people we throw into the mix, the more time we're going to spend on coordination and communication. And you also very easily end up with what I call overcrowded systems, where you write a piece of code yourself today, then you look at it 3 days later, it looks completely different because 5 of your colleagues have been working in the meantime. That means you have to relearn that code, which means you're going to be in a constant onboarding mode, which is really, really expensive. Or you will make changes to that code based on outdated understanding of how it works and you will create a bug. So an overcrowded system is heavily correlated with us increasing bugs. And I've seen that happen so many times. And again, I think the reason we make these mistakes is, first of all, it's we kind of fail to learn from our history, because Fred Brooks, he wrote about this in 1975 in the Mythical Man Month, right? But most people don't read, but the information is out there. The second is that we have this delayed feedback loop. We cannot see what happens in the code. We will only figure out once we miss that first deadline. And then we still hold on to the hope that, yeah, but we're going to fix this in 2 weeks or 2 months or 2 years. So again, having this visual data, visualizations and data on how healthy our code actually is, how healthy our ecosystem of code and developers are, that's super critical to the modern software organization.
And I know it's so funny because you mentioned Mythical Man Month and how he wrote about it in 1975. And I always think that, hey, I have read this book. Now, how do I make my client or manager or skip level, how do I make them read it? So this is one of the tough things. Once you know something, but it's very hard for you to convince others when something like this is so counterintuitive. Because one of the biggest solutions to any problem that I have seen in our industry is, let's throw people at it. Like literally get more consultants, get more team members, let's create like more bigger teams, bigger scope, and people really think that it goes that way. Then I have never in my career seen a project where, hey, just because you brought 20 more people, it just kind of, becomes successful. It doesn't necessarily happen that. Not that adding people doesn't add value, but it has to be very carefully planned. And I think that's why, let's switch the gears a little bit. I was just talking about this to someone else lately. Have you felt this, that because people have been like, as the teams increase, people are going to use things like microservices, your code bases, like individual code bases are going to be much smaller. Testing is going to be much easier, faster. Your file sizes are smaller, your release cycles are faster, so you're not batching a lot of things together. So does it automatically bring technical debt down? So let's say, is it fair for me to say, hey, just because you're using microservices, you'd have less technical debt?
No, I don't think we can make any such claims. I think that it's a little bit what we touched upon earlier, that you can indeed scale a software organization if you let the technical architecture scale along with it. The thing is that on architecture in that context is never purely technical. If you're a true domain expert, then we identify that, okay, these parts of the domain are separate enough that there's not much need for coordination between people working on that domain and that domain. And if we manage to represent that as technical building blocks, could be microservices, could be a subsystem or a module, then we can indeed have teams that are fairly independent, that can basically have their own, backlog and be domain experts and make a lot of progress in parallel. What I see in practice, however, is that it's extremely hard to pull that off. What I see in many microservice systems is that they don't necessarily have that clear-cut domain separation. Rather, they tend to end up with, being partly technical concerns represented as services. And what happens when you do that is you end up having all that coordination and communication across team boundaries, which is even more expensive. So I think it's super hard. I think increased modularization, if that services, whatever it is part of the answer. But it requires very much that we as software architects, we need to be absolute domain experts to pull that off, work very closely with the business and be prepared to reevaluate all the time.
Agreed. And I see few questions in the chat, but before that, I had just one last question. LLMs and artificial intelligence is doing so much. Has brought so much change to how people develop code just in last 1 year. And I can't really believe it that it's just been a year. OpenAI and ChatGPT became so famous. What do you think? How will it help or harm the world of software development?
So how it will help, I think it's too easy to answer. We have no idea what these techniques will look like 3 years from now or a decade from now. But I think a very safe assumption is that for the next 20 years, we're going to have a hybrid model where we have code that's partly written by AI and partly by humans, right? And humans need to be able to understand both the human written code and the AI generated code. So what I think that means is that the stuff we talk about, code quality, technical depth, is going to be even more important in an AI-assisted programming world than it used to be. It's super critical. So we really need to have this gold standard on all AI-generated code. We should never, ever accept technical depth from an AI. So that's one part of it that I think is our responsibility. The second thing is who's really benefiting from it. I think that that's also partly answered because there has been some studies on it. As a junior developer or as a perhaps senior developer learning a new language, I can benefit a lot from these AI-assisted coding assistants. I think there are some trade-offs, and the trade-offs are that these machines, they make it so easy to write a lot of code that shouldn't have been written in the first place, right? That's where I see them creating a lot of potential problems. I also think that the machines are they're pretty low on accuracy. So if you look at Copilot, Code Whisperer, if you look at the data from them, you see that the code that they create is correct in maybe 1/3 of the cases. So that means in 66% of the time, they are creating some kind of bug or showing erroneous code to you, which puts a lot of cognitive load on you as a developer, because now you have to be, the reviewer of that machine-generated code. So I think that's a big responsibility. So these AI assistants, they're not really free, right? They're creating a lot of job for us that we have to be very conscious about. And I've seen so many examples on that. So I think it's early to tell, but I think there are other long-term implications too. And one is that we also have to question a little bit when things become too easily accessible. What does it do to our expertise? If I can just use an AI assistant to kind of generate some boilerplate code for me, as opposed to me having spent time reading a manual, really understanding an API, are there going to be any differences in quality between our solutions? Are there going to be any differences in my expertise over time if I really master something versus just copy pasting some code from an AI assistant that I don't really understand? So we really have to question all these things all the time.
Agreed.
Long answer.
Agreed. And no, I think it makes total sense. And as I said earlier, I think inability to write code faster was never the problem. So yes, AI is going to write a lot of code very fast. That doesn't necessarily mean it solves a certain kind of problem. It may actually increase a lot of problems as well. And you're also right. I think a lot of people, this is something that I say as well, that hey, developer's job is not to know syntax, right? Syntax is not the primary job. Like I know the syntax of Java or JavaScript or TypeScript or Go or Rust is not the primary job. So that's actually good that if developers could get like helping hand and knowing syntax, being able to write code and help us the right help at the right time. I also saw that AI does help you stay in the state of flow. So you're not like really browsing through different places and reading irrelevant things. You're really focused. Um, as far as you can kind of fight the AI hallucination. I think as far as that happens, I think you're right on the path of getting the information in the fastest way possible. But we have last 5 minutes, Adam, and I want to talk about this is one of the most common question that comes to our mind. Whoever has been working with external clients, right? Where you're actually rendering services for someone, and when you're rendering services for external clients, the only focus that they have is being able to deliver feature faster, right? So how do you deal with something like that? Because code quality is not the measure or parameter that they necessarily care about.
So it depends on the type of situation you have. If you're building a new system for a client, then it's really, really good to know that there is no trade-off whatsoever between speed and quality, right? In fact, you need to have high quality code in order to be able to iterate fast. So in that case, it's I would say, in your best interest to make sure that you have a really healthy code base, because only so can you ship features really fast and maybe, positively surprise the client that you're able to keep that up. If on the other hand, which I think is also common, you take over an existing system, you're supposed to build on top of that, then I think it's really important to know what you're taking over, what the situation there is, and have a conversation with the client around it. So I would use the same techniques as we just discussed before to show them that, look, we have these unhealthy pieces of code here where you want us to go fast. It's simply not possible, because if we've seen the research, it might take 10 times as long. So do you want us to first clean this up so we can go quick then, or should we accept this 10x slowdown? That's the type of conversations you can have.
Makes sense, Adam. Makes sense. Awesome. And I think that's a wrap, Adam. Do you have any other thoughts that you would like to talk about?
Oh, we covered so much ground today, so I'm kind of happy with that. It was a nice conversation, always interesting to talk to you, and I'm really happy to be able to meet the community. So thanks a lot, everyone, for spending this hour with us.
Thank you. Thank you so much, Adam, for joining us. I really hope we hear about your new paper as well as the new product real soon. Would be more than happy to post it on our community as well.
Thank
Thank
you.
you. Thank you so much. Bye.
Bye.